demonstrate the absolute and evident modernity of Tripura Vimana. This Vimana is taken from Vaimanika Shastra by Bharat Maharshi. So we are imagining Tripura Vimana modernity in underwater drone. So I'll just give the overview of my research. First one is I'll introduce everything basics to my research, then I'll show my designs, then I'll show my simulation assemblies, then I conclude with simulations. So to introduce Vimana, so there is a Vimana Shastra written by Bharat Maharshi. So in that there are many Vimanas which are given to us. In that there is Tripura Vimana. This Tripura Vimana is multi-mode. It can work in air, on land, and in and on water. So it has multifunctional capacities. So you can see this is not the proper structure, but this is the good picture to show you that there are 3 puras. So this is called Tripura because it works in 3 puras. So 3 areas. So 3 areas are called 3 puras. So it is called Tripura Vimana, and it has 3 floors which is dedicated to each area to work upon. So now we have Tripura Vimana, but our research is on imagining Tripura Vimana as an underwater drone. So there are many drones as of now, but the problem with advanced drones are if you go in one way, it shows only the direction. If you want to see other angle, it cannot see the other angle. You have to move the whole body. So, but there are many advantages with Tripura Vimana, with the design and the internal components within it, because it facilitates the good components in it. So here I want to tell small line about the underwater vehicle. So underwater vehicle is an unmanned vehicle, which is, we don't need any operator to operate within it. We can just control it from the outside. We can take the input and give the out. So this is the introduction. So from here my co-author will take over.
Hi, my name is Shiva. So from here I'm going to continue. Like coming to the design part, the main thing like the bridge is the components which we have considered are from the book Vaimanika Shastra. So we try to take all the components mentioned in the books and try to integrate it into a design. So the design contains 3 floors. So basically the first floor is mainly related to the, as we said before, the Tripura Vimana is mainly used for 3 modes. So the first floor is mainly for the links for the travel on roads. So, and also it can also be used when we are near to the water surfaces also. So it's not like, for example, right now the ships and everything what we have right now, it's not like they can come till the docks and everything. So if we can integrate the wheels into this, it would be great, so that we can get even the ships till the shore as well. So that is the main part of the main purpose of the first floor. And coming to the components it contains, coming to the back room, the main purpose of the back room is to, The main purpose of the back room is to facilitate all the mechanisms related to the rotor mechanism systems, and whereas the front room is mainly for to ensure all the mechanisms for the propeller, which is placed in the front. And as well in the back itself, we also have an electric power unit room, which facilitates all the power necessary for the complete floor, and which has the connections through the above the roof. And the roof is placed approximately 7 feet from the pita. And in each floor, there are all the 3 floors contains the air pipes which keep the constant air circulation for the fresh air. And although it is a unmanned vehicle, previously Tripura Vimanas were used for traveling with the people. So we ensured that all the air pipes and everything, all the display units and all are exactly the same. And the main purpose of the second floor is to maneuver in and on the water surface. So we have 2 ballast tanks placed in the 2 corners of the pita. So whenever we try to move underwater, we try to fill them, and when we want to move, we just try to propel the water out of the tanks. And coming to the third floor is mostly about the control units and everything. Like the control unit is where it controls automatically based on the attitude and everything. It controls the whole Vimana. And the other room is for the power generation room. And the other one are the air pipes, which we are mostly concerned. So coming to the assembly, we designed all the 3 floors separately, and we later try to integrate them, and using few features we try to close. And coming to the simulations part, since we didn't consider all the lohas exactly, but we tried to consider the closest ones. So we took 3 materials and we tried to apply the pressure like as the same amount of pressure what the Vimana would be facing if it is underwater up to 5 kilometers. So according to that, we tried to simulate for all the 3 materials. And coming to the usages, the main usage of the Tripura Vimana would be, as this is for the underwater drone, the main purpose of designing this Vimana is so that to see that when we try to go into the underwater surface, we want to study and analyze the ecology of the underwater. So that is the main usage of the Vimana for what we have considered. Because this is not the Tripura Vimana, but this is the Tripura Vimana which we are using it as an underwater drone with the modern technologies. So it is not the exact model of the Tripura Vimana. So in the future, in the future, it would be great if we could come up with the materials that have been used in the Tripura Vimana, because the lohas and everything are, we could say that we have never seen the materials or anything. It's state of the art, we can say that as, because a material which can be used in all the 3 areas, like when we are in the air, we want the material to be as light as possible so that we can have free motion in the air. Whereas when we are in the water, we want it to be as heavy as possible so that we can maneuver, we can go as depth as we can. So having a material which can be used in both the areas would be like state of the art. So it would be great if, like, we are trying to do the research for the future papers, we want to try to do the research on the materials if possible. And we are also trying to integrate all the components which I have mentioned before into the original model and do a scaled down version of it in the future paper. So coming to the conclusion, with the help of all the data and everything we have considered, like all the simulation results, I think with the 3 materials which I have taken, this is the best material as of now. And before I get into the lohas and everything, as of now, what I have, I think this is the best material out of the 3. So, and the references we have been taken from the Vaimanika Shastra from Bharat Maharshi. Thank you.
Thank you, Srimati Sahiti Garu and E.Siva Sankaram Garu, for your valuable speech. I would like to ask Session Chair Dr. Vikas Kumar Saxena Garu to present memento, shawl and certificate to our speakers.
Before that, I think they kept in time. I just want to know 2-3 questions because it's very interesting. Can I ask two questions? Because
Yes.
you have used this because you are talking more, it is underwater. So I was just thinking underwater navigation. Are you going to use some sonars for that, or because the underwater navigation sonars, because you are taking this directly from this Viman to for underwater application. What kind of navigation you are thinking about underwater?
There are many communication systems. We are trying to figure out the best communication system and the power system too. Because in Tripura Vimana, they are using the solar panels. But in underwater, we don't get the solar, right? So we are thinking of
Yeah.
first power, then communication.
Okay, you can think of just other thing because you are talking about ASTM A36. Because underwater, I don't know, you might have taken from the ASTM handbook, the material which you use underwater, it should be highly weldable and amenable to stress corrosion cracking. Because if it is not there, it will crack at the weldments. I don't know what kind of structure you are having. So this is very, very important. Look at the corrosion property when you go for. And titanium alloy, I think you have used 6L, that is a beta titanium alloy, we call it.
Alpha beta.
Beta, it has got very high fracture toughness. Look at, because it is highly alloyed. It's the weldability aspect you must study because you are taking forward this research. And other thing I just want to, because you are taking materials more, maybe some research lab like DRDO. DMRL, we have developed some AB grade of steels, which we have worked for Vikrant applications, we have made. Other thing, IIT Madras, you can connect with them. They're a department of oceanography. Other thing, I think one of the sponsors, I think NSTL is there, Visakhapatnam. They have got underwater testing. You can do all your testing there under that.
Helpful.
Pardon?
That would be really helpful.
Helpful. And if you want this lab or our lab, DRDO can help you doing a stress corrosion cracking test under sea environment, I think 3.5% NaCl also. I think I was involved in this program. So it's very interesting. Thank you.
Yes, thank you.
Just to clarify, sir, there are three materials here, right? We are just here to show the simulation to keep some metal, we put that, but we are trying to research more on Trinetra Loha, which is actually used in Tripura Vimana.
You are doing that with the technology, so you have to study those properties.
Yes, because of that material.
It's a damage tolerance property underwater. Because even this material may be very good, you have taken from SDM. Underwater, its property will come to 1/5 only.
Yes.
So that is what, once it cracks, you know
Yes.
what will going to happen inside,
Yes.
especially welding area.
Yes. Yeah. Thank you, sir.